Okay, good day everyone. Welcome to another discussion in general mathematics. This time we will have conditional statements. These are the objectives. And these are the questions that you should be able to answer at the end of the discussion. Okay, in the previous discussion, we discussed conditional statements. So this is the symbol. And this is any statement that can be written in an if and then form. And this if and then statement has two clauses. You have the hypothesis or premise and the conclusion. So if the statement is not written in an if and then form, we can determine the hypothesis by using these indicators, and this will be the indicators for the conclusion. So we have for if then we have when and only if. You have because, hence, follows, you can also use hence, and then from, therefore, and since, thus. So these are the indicators for the premise or hypothesis and conclusion. Okay, I also gave you examples on how to rewrite the statements in an if and then form. So these are the examples that I discussed in the previous video. You may rewatch it or go back to that video for the detailed discussion. Okay, so of course you have to determine first the premise and the conclusion so that you can write it in an if and then statement. Okay, so let's have this example. Underline the hypothesis and encircle the conclusion in each of the following. Rewrite the sentence if it is in if and then form if needed. So for this one, you have number one, if you are a reader, then you are a learner. This one is already in an if and then. So your hypothesis is underlined if you are a reader, and your conclusion will be then you are a learner. So for number two, when you need a friend, just call me. This one is not yet in if and then, but you have the premise indicator when. So therefore, when you need a friend is your premise, just call me will be your conclusion. For number three, if angle A and angle B are complementary, then measure of angle A plus measure of angle B will be 90 degrees. Again, this one will be your hypothesis, and measure of angle A plus measure of angle B is equal to 90 degrees will be your conclusion. Okay, let us continue. All athletes are healthy. So this one is not yet written in an if and then form. You have to determine first which is the hypothesis and which is your conclusion. So therefore, your hypothesis here is all athletes and healthy will be your conclusion. So we can write it this way. If you are an athlete, then you are healthy. So this will be your premise and this will be your hypothesis. Your conclusion. For next number, no one wins in a war. Of course, your premise will be in a war, and no one wins will be your conclusion. So we can have if countries engage in a war, then no one wins. So this is your hypothesis, and then no one wins will be your conclusion. For the last number, perpendicular lines form right angles. So we can have this one as if two lines are perpendicular, then it form a right angle. So this one will, if two lines are perpendicular is your hypothesis, and it form a right angle will be your conclusion. So this is how you change it into an if and then form. Okay, from conditional, we can also create additional statements referred to as related conditionals. This include the converse, the inverse, and the contrapositive. So what is a converse? It is formed by converting its premise to a conclusion and its conclusion to a premise, or simply interchanging the hypothesis and conclusion. For example, if we have the conditional statement, if it is cloudy outside, then it will rain. So to form the converse, we will interchange the hypothesis and premise. So we will have this symbol, converse. If it rains, then it is cloudy outside. This time, let's have an inverse. So this is formed by negating both the premise and the conclusion. So when we say negating, we just get the opposite the opposite truth value of the statement. So the same example. So this time we're going to negate the conclusion Q and the premise P. So you will have now the inverse statement. If it is not cloudy outside, then it will not rain. So this is how you get the inverse statement. Okay, for contrapositive statement, this will be your symbol, the negation of Q and negation of P. So it is formed by interchanging the hypothesis and conclusion, and then you're going to negate both. Again, for the same given, so we're going to negate the conclusion and the premise or hypothesis and then interchange. So your contrapositive statement will be, if it will not rain, then it is not cloudy outside. Okay, let's have an example. Let's have this statement, a square is a rhombus. So this is not yet written in an if and then form. So the first thing that we're going to do is to write it in a conditional statement or if and then. So we can have, if a geometric figure is a square, then it is a rhombus. So from here, we can now get the converse, inverse, and contrapositive of that conditional statement. So for the converse, we simply interchange the hypothesis and the conclusion. So we will have, if it is a rhombus, then the geometric figure is a square. Okay, so for the inverse, we simply negate the premise and conclusion. So we'll just go here and then we negate both. So that will be, if a geometric figure is not a square, then it is not a rhombus. And to form the contrapositive, we just simply negate the converse. So you can have it this way, or you can copy this one and interchange yung inverse. So that will give us, if it is not a rhombus, then the geometric figure is not a square. So this is how you change a statement to its conditional and to its related conditional, the converse, the inverse, and the contrapositive. I hope it is clear. Okay, let's have another example. You have, if you are not confused, you are not paying attention. So from Tom Peters. So this is already in an if and then. So let's have now the converse. Simply interchange. If you are not paying attention, then you are not confused. And for the inverse, so let's just negate the conditional. If you are confused, then you are paying attention. Okay? And then if we have the contrapositive, let's just interchange the inverse. If you are paying attention, then you are confused. Okay, so this will be the answer for this statement. Okay, now let us remember this concept. Contrapositives are logically equivalent to the original conditional statement. For example, if the conditional statement is true, then the contrapositive is also true. And if the conditional statement is false, then the contrapositive of that statement is also false. Also, the converse and inverse of a conditional statement will always have the same meaning. So you have to remember this one. Okay, for example of equivalent statements, if we have the conditional statement, if the car will start, then the battery is charged. So to get the contrapositive, we will have, if the battery is not charged, then the car will not start. So if this one is true, the conditional, so this one is also true. So they are just simply equivalent statements. Now, if we have the converse statement, if the battery is charged, then the car will start. So the equivalent statement for the inverse will be, if the car will not start, then the battery is not charged. So again, from the key concept, we know that converse and inverse have the same meaning. Okay, to sum up, these are the table. So you have here the statements. Okay, so conditional, converse, inverse, and contrapositive. And we have here the rule on how to convert it, and these are the symbols. Okay, so let's have the truth table. I also gave this one to you on the previous lesson. So we have the truth table conjunction, for conjunction, disjunction, and conditional. So for conjunction, it is only true if the two states, if both statements are true. So therefore, the conjunction will also be true. Now for the disjunction, it is only false when both statements are false. And for the conditional statement, it is only false if the hypothesis is true and the conclusion is false, so the conditional statement is also false. So this will be your guide in determining whether the statements are true or false. Okay, let's have an example. Write the if-then form, the converse, the inverse, and the contrapositive of the conditional statement. And then let us decide whether the statement is true or false. So let's have example. Guitar players are musicians. So first we have to write this one in an if and then. So we can have, if you are a guitar player, then you are a musician. So this statement can be considered as true because if you are playing a guitar, you can be considered a musician. For letter B, converse. So we just interchange the premise and the conclusion. So you will have, if you are a musician, then you are a guitar player. Then this one is false because not all musicians play the guitar. Some musician can play piano, saxophone, or others. So it doesn't necessarily mean na you just play guitar for, for you to become a musician. For the inverse, if you are not a guitar player, then you are not a musician. So this one is also false because even if you don't play guitar, but if you are playing other instruments, or for example, you are not playing instrument but you are a singer, so you can still be considered a musician. And then for the last one, the contrapositive, if you are not a musician, then you are not a guitar player. So this comes from this one, sa conditional statement natin. So this one is also true. So because a person who is not a musician cannot be a guitar player. And we know that the conditional and contrapositive have equal values, or they are equivalent statements. So this is how you determine the truthfulness or the truthfulness of the statement. Okay, let's have counterexample. So this one is an example to show that the statement is not always true and therefore it is false. So for this, you must keep the hypothesis true but the conclusion is false. For example, find a counterexample to prove the statement is false. If x squared is equal to 81, then x must equal to 9. So your counterexample for this statement will be x could be negative 9. Because when we have the square of negative 9, that is also equal to 81. So, but x is not equal to 9. So therefore, this one is an example of counterexample. The hypothesis x squared is equal to 81 is true, but the conclusion is false because from 9, you gave a counterexample of negative 9. So, I hope that is clear. Okay, let's have additional example. Show that each conditional is false by finding a counterexample. Number 1, if an animal is a bird, then it is a penguin. So we can have a counterexample. The bird could be a dove. So if an animal is a bird, then it is a dove. So you find a counterexample which makes the conditional statement false. Okay, for number 2, if a number is divisible by 2, then it is divisible by 4. So your counterexample could be, if the number is 6 is divisible by 2, but not divisible by 4. So 6 is an example of a number which is divisible by 2, but not divisible by 4. So this is how you give the counterexample of a conditional statement. Okay, let's have biconditional statement. When a conditional statement and its converse are both true, then the two statements may be combined. So we will be using the word if and only if, and this is your symbol. So this one. Example, if you have the statement, if an angle is right, then it has a measure of 90 degrees. So this is your conditional. To get the converse, so we will just interchange the premise and the conclusion. So you will have, if an angle measures 90 degrees, then it is a right angle. So both statements are true. So therefore, we can have the biconditional statement, an angle is right if and only if it measures 90 degrees. So this is how you form the biconditional statements. Again, if the conditional statement and the converse statement are both true. Okay, let's have another example. This time we're going to use the definition of perpendicular line and to write it into a biconditional. So the definition states that two lines intersect to form a right angle. They are perpendicular. So we just insert the word if and then so that we will now have the conditional statement. And then to get the converse of the conditional statement, we just interchange the premise and the conclusion. So we will have, if two lines are perpendicular, then they intersect to form a right angle. And since the definition or the conditional and the converse are both true statements, so we can write it into a biconditional. Biconditional statements will be two lines are perpendicular if and only if they intersect to form a right angle. So this is how you do or you form the biconditional statements. Your conditional and your converse should be both true. Okay, to sum up, please remember the following concept. The original conditional statement and its contrapositive will always have the same meaning. The converse and inverse of a conditional statement will also have the same meaning. A conditional statement is equivalent to its contrapositive, and the converse and inverse are also equivalent statements. Okay, that ends our discussion for today. Visit the Google Classroom for your output and kindly subscribe, like, comment, and share. Thank you.